All right, so we're practicing net force. At the top, I want you to write net force because that's really what this is called, balanced and unbalanced forces. And this is worksheet number 1. You guys are gonna end up doing the second one on Friday. So it says a driver and a passenger get out of their car that has run out of gas on a city street. They cannot agree on which gas station is closer, so they begin pushing with equal force on opposite ends of the car. Make a sketch of this car pushing situation using arrows to represent the forces on the car. So somebody give me the keywords that I need to circle so I know what I'm drawing here. Give me the keywords that are going to indicate what I need to circle. What I need to do. Ethan. All right, so they ran out of gas. So that would indicate that they are not moving, right? Mazzy. Equal force, and then what other word? There's 2 words. Caroline. Opposite ends of the car. So how do you think I would draw this? First, let's draw our car. It's got a really big bumper. Beep, beep. That's my car. It kind of looks like a dog. Whatever, man. I've done better, but it's what we got. So I've got opposite ends. So I'm going to draw one friend here and one friend here. What direction would my arrows be going in? Carlos? Yeah, so this guy's going to be pulling it to the right because he thinks that this gas station is better, or that there's a gas station that's closer over here, and she's going to be pulling it to the left because she thinks this gas station is closer this way. Or it could be the opposite, right? One could be pushing, he could be pushing to the left and she to the right. Who's negative in this example? The girl or the guy? Who's negative, Caroline? Remember a number line. The girl, right? If we think about our number line, draw our number line up at the top. If you're pushing to the left, you're negative. The left or backwards. And if you're to the right, you're positive. So our guy is positive and our girl is negative. Now we did not include numbers, just vectors or, just those arrows. But using this sketch and what we know about what the question asked, are our forces balanced or unbalanced? Are forces balanced or unbalanced? Brennan, balanced. Why do you say that? Yes, so we can say balanced because they are on opposite sides, right? If they were on the same side pushing with equal force, what would that do? If they were both on the same side pushing on with equal force, there'd be more power in one direction than another, right? Or more force in one direction than another. So because they are on opposite sides, pulling with equal force. In opposite directions. And I know that they're opposite directions because it says that they cannot agree. We didn't circle that. They cannot agree. If they agreed, they would be pushing, they could be pushing from opposite sides, one pulling, one pushing, right? Yes, ma'am. Yeah, so if they're both pushing, then she could be on this side pushing the car this way while he was pushing it the other way. Yeah, that would make sense. Good thinking. Good thinking. Way to pay attention to those context clues. Now we're going to redraw the sketch with force arrows illustrating a more effective way for the driver and passenger to get to the car to the gas station. So this gives me another chance to redeem myself in my car drawing. Much better that time, I think. Still looks like a turtle. All right, so somebody, let's brainstorm some ideas. My mobile friends, give me some ideas about what you think might be a good way for them to successfully move this car. What would be a better way instead of them on opposite sides? How could we actually move the car?
They should be on the same side of the car, then they should push it.
Very good. So let's put them on the same side of the car. Teamwork makes the dream work. And she's going to push with the same amount of force, and he's going to push with the same amount of force. Is this balanced or unbalanced? One of my mobile friends, not Ariana, since she was our friend that suggested this, but I want somebody else. Is this balanced or unbalanced?
I'm pretty sure it's balanced.
Oh, think about it. So remember, balance would mean it's equal on both sides. Is it equal on both sides? So what is it, Micah? If it's not equal on both sides, what is it?
Unbalanced.
Unbalanced. Very good. All right, so we're going to say unbalanced, and who thinks they can give me a good explanation of why to write? Ethan. Unbalanced because, give it a shot. Unbalanced because there's only one, there's no people on the other side. What do you say, Brennan? So there's, okay, because there is no force that is equal on the other side, right? Let's use that keyword equal, because remember, a synonym for balanced is equal. So unbalanced because there's no force that is equal on the other side. Very good. Still gonna draw my windshield here. The car got smaller. Does everybody follow me there? Okay, good. I'll give you a second to catch up. It says, the next one says, a float plane lands on a harbor. You guys know what a float plane is? Okay, one with the floats at the bottom. Okay. When the floats touch the water, the plane slows down. Are the forces on this plane balanced or unbalanced? Explain. Keywords. Keywords. Bishop. Okay, balanced and unbalanced. What else? Ayana. Slows down. Okay. What do we know from our notes that we took the other day about if something slows down? What do we know, Emerson? Why? I know it's hard to put into words. Think about take a look at that back sheet from our notes from before. What does it say? What does it say in our chart? Go ahead and give it a shot. Keep going, Emerson. I want to give you the shot. You got it? You can phone a friend for help if you want. Hey, you were off to, you gave her a good start. Very good. So I know that I'm unbalanced, and I'm just going to kind of reference our notes really quick. If I'm balanced, I'm either resting or not moving, right? Or I'm moving at a constant velocity. That means the same speed and direction. According to this example, I'm slowing down, which means I am changing speed, correct? In this case, I'm decelerating. We also know that acceleration is when I change my speed or my direction. So if I'm slowing down, that means I have more force pushing what direction, forward or backwards? Right? Not more, but an increased amount of force pushing me backwards because I'm still going forward, right? But I have an increased amount of force pushing me backwards to slow down. What is that force called that's pushing me backwards? What's the force that's resisting me called? Carlos? It is friction, absolutely. So we're going to say that these are unbalanced because when I change speed, I am accelerating or decelerating. Which indicates a change in force. I could also represent this by saying when we're balanced, balanced equals resting or constant velocity, which means I'm not changing direction or speed, right? Don't forget to write that part. If I'm balanced, it means I'm resting or I'm going the same speed or direction. Does that make sense? If I'm slowing down, it means I have an increase in force on one side. It doesn't mean that it's greater. It just means that there's, because I'm also still moving. If I'm slowing down, doesn't that also indicate I'm still moving? So we could say still moving. Oh, I said stilling. Still moving, but I'm changing speed. If I'm still moving, I can't be resting. And because I'm changing speed, I can't be at a constant velocity. Because we know from our previous notes that velocity is a change in speed or a speed and direction of a moving object. if it was the same speed and direction, I wouldn't be decelerating. Does that make sense to everybody? Okay. And we already kind of answered this, but what type of force does the water exert on the plane's float, which causes it to slow down? Remember that what's causing it to slow? Remember, it has to be in what direction, forward or backwards? Backwards, so it's going to be resisting and making it go backwards. What is that force called? Friction. Very good. Now, this one's asking you to sketch it. If you're mobile, you can either just insert arrows or you can insert a clip art. I'm not asking you guys to draw like the best plane or anything like that. We're just drawing a plane. With some floats at the bottom. Bam. Now, because I'm still moving, and I'm still moving in what direction? Emerson? You're still moving forward, but if I'm slowing down, I now have a force acting in the resisting. So which arrow would be bigger? Which arrow would be bigger, the one moving forward or the one moving backwards? Which one would be bigger? Remember, forward, because I'm still moving forward, right? I'm still moving forward, so the force of me moving forward, that force of the engine is still at this point greater. But I do have some that is pushing me backwards. Because I have more I'm still moving forward. What other forces might be acting on this plane that we talked about? Think about the car example in our notes. What other forces might be acting on this? Think about the car example. What other forces were acting on it, on the car? There's one definitely. It is a non-contact force. Caroline? Gravity. So what direction would that be going? Down. Yeah. Otherwise, the plane would be floating. So we've got friction. We've got the weight. What kind of friction? Not only do I have friction at the bottom, right? Both of those are friction. But what is the friction acting on the front of the plane? Not between the water and the bottom of the boat. But, so they're still moving, but what is that called? The friction, what is the friction of air called, Emerson? Drag, also known as air resistance. Also known as drag. And then this would be the force of our engine pushing us forward. We have the reacting force of the water, which is pushing up. But let's keep it like this for right now. We've got the force of gravity pushing down. We've got friction between the water and the boat, air resistance and drag. But we know that it's still moving forward because it's slowing down. It never said it started moving backwards, right? Thumbs up when we're ready. All right, so let's flip it over. Now we're gonna practice. This is us just practicing the math. We're gonna do this paper, and then we're going to do just a couple random practice problems that will prepare you guys for Friday and next week. Christian. Yes. Assume that the wheels of a car apply 10 newtons of force forward. So we've got 10 newtons of force forward. Add a force error to the picture showing the situation. What is the combined force if friction and drag are negligible? What does the word negligible mean? Does anybody know what negligible means? If I said the word negate, what does that mean? Okay, so I'm glad that you said it sounds like the word neglect, right? All right, so what does it mean if I neglect to do something, what does it mean? I what? Put it off, or I stop or don't do something, right? So if it's negligible, it means negligible means it cancels out. Negligible means like insignificant. Well, not that it cancels out. It just means that they're insignificant. So let's rephrase that. So if they're insignificant, what would that mean? What number do you think it means? Insignificant. 0. So I've got 0 in the back direction. So first of all, is that 10 negative or positive? Positive. So what would my net force be? Equals 0 plus 10. 10 newtons. In what direction? To the right, forward. Now, what if I had 10 backwards? So then it would be negative 10 plus 10, and I would have 0. Because negligible means to, like, and to me, any other time that I've read this, I've been thinking like negligible meant like it canceled out. So if it canceled it out, what would that be? If it canceled it out, if they were, what would that mean? Emerson? It would be balanced. So that way we're interpreting it in both ways. All right, now assume the parachute opens and applies 7 newtons of force in the other direction, opposite to the 10 newtons of force being applied by the wheels. So we know the wheels are in what direction? Forward, positive 10 newtons, and we know that we now have drag in what direction? Backwards, positive or negative? Negative 7 newtons. So our net force equals, somebody tell me the equation. What's our net force equal? Carlos. What? I need the equation first. We're negative 7, 10, right? Negative 7 newtons plus 10 newtons. The easiest way to decide if I'm going right or left, which do I have more of, 10 or 7? 10, so I'm going to take that sign. Does that make sense? I have more in that leftover. So I know I'm positive because I have more, 10 is more than 7, right? How many more than 7? 3. Positive 3 newtons, and what am I missing? I'm missing something. Force has size and direction. So what am I missing? All right, so what direction am I going? Forward to the right. Very good. Very good. Yes. Yes. Any questions so far? Because the numbers are going to get bigger, but it's the same concept. All right. A rocket applies an additional force of 10 newtons to the 10 newtons that are applied by the wheels. So I've got my positive 10 newtons by the wheels. What should I draw for the rocket? What should I draw for the rocket? What should I draw for the rocket? What, 10 newtons of what? Where? Forward, backwards. Forward, right? Positive or negative? Positive, very good. And I still have the parachute. What does that indicate? Negative, meaning I'm going to the left, negative 7 newtons. All right, so balanced or unbalanced? Unbalanced. Somebody tell me what my equation is. Somebody tell me what my equation is. Ethan? Net, catch all of it in the net. Positive or negative 7 newtons? Negative 7 newtons plus. Very good. And you see how I put the negative one first? Now, do I have more positives or negatives? So my end sign is going to be positive by how many? By 13 newtons. Very good. And what am I missing? And my direction is forward. All right. So here we have a plane. We've got thrust. Thrust is the same thing as the force of an engine. We've got drag, which is also known as air resistance, which is also known as resist. What is air resistance an example of? Friction. You guys are amazing. Weight, which is the measurement of the force of gravity. And lift. Lift is because it is that reaction force that we talked about, remember, with the car, but specifically with airplanes because of the way the wings are shaped. Have you ever noticed airplanes have the wings go? Yeah, and that's so that they can pick up the air. Have anybody seen the new Wonder Woman? No? Okay, no. Okay, you saw the new Wonder Woman. So you know how you both did. So you know how the pilot explains about how you can like feel the air carrying you because that's because the wind is pushing up underneath the wings to keep it afloat, right? So all right, so in this instance, I like that it kind of tells us the condition. So if lift is greater than the weight, the plane's gonna go up. That makes sense because the arrow's up, right? If the weight, the down arrow, is greater than the lift, so if we've got lift greater than weight, it's gonna go up. If the weight is greater than the lift, it's gonna go down. If drag, and for the purpose of this, we're gonna flip the plane. I don't mean flip it, but we know drag to be pulling us backwards, right? You see how the plane is facing this way? So really forward for the plane would be this way, meaning that forward, even though it's to the left, this would be positive. Does everybody understand that? Because the plane facing forward is positive. Does that confuse anybody? All right, if you see it facing forward, but forward is to the left, you have to change your mindset, right? Because forward is positive. So if the drag or air friction is greater than the thrust, it's going to slow down because friction is slowing it down. And if the force of the engine is greater, the plane is going to accelerate, or what's another synonym for accelerate? Speed up. Very good. Okay. An airplane has a weight of 100,000 newtons and a lift of 75,000 newtons. Which one is going to be my positive here? Which one is positive? Think about it as a number line. It's really subtracting here, right? It's not really a positive or negative thing, but how am I going to figure out my net force? How am I going to figure out my net force? Because we've never done it up and down before. What do you think, Emerson? Yeah, so we're going to do 100,000 minus 75,000. And because the lift is going up, it's going to be our positive. So 75,000. Let's do it backwards, actually, sorry. Nope, we need to be careful. Because we're going up, that's going to be our positive. Our weight is down. Which one is greater? 100,000. So is the plane going to go up or down? Down. Okay. So the combined force on the airplane, if weight is negative, we're going to do negative 100,000 plus 75,000 because 75,000 is up going positive, right? So is negative 25,000. Are they balanced or unbalanced? Unbalanced. And what's going to happen to the plane? It will fall. The only reason I'm making lift positive and weight negative is so that you understand that it's going to fall, right? And if we're going up in the air, we're associating that with positive, right? Because you're going up, like adding up, adding height. A plane has a thrust of 200,000. So is thrust positive or negative? Positive, because I'm going forward. And a drag of 23,000, positive or negative? Negative. Somebody tell me what my combined force is. My net force. Give me the equation. Carlos? It is minus, right? But I want us to write, just so that we don't get lost, put the negative number first. So you don't lose track of that negative sign. Because you know, when you see a plus negative, isn't that confusing sometimes? So we're going to put our negative number first, negative, and we know when we're combining forces, we're adding. So I don't want you guys to get lost there. Negative 23,000 plus 200,000. Which one is bigger? The 200,000, so I'm positive or negative? Positive by how much? 177,000 newtons. Balanced or unbalanced? Unbalanced. And what's going to happen to the plane? It's going to accelerate. What direction? To the right or forward, yep. Does everybody understand that? I know this one was a little more confusing because the plane is facing a direction we're not used to. We also haven't talked about lift being positive, but if you think about it, if I'm lifting up in the air, aren't I adding height? So if I were to flip the paper, my positive would be to the right, my left would be negative. Does that make sense? Okay. I want to do a couple practice problems with you guys. So if you have, yes. If you have a
Shirley,
blank, yes,
can
love?
can you go back down?
There you go, honey. If you guys have a blank sheet of paper or if you want to write it somewhere maybe on the front, we're only going to do a couple of them, okay? Just to get you ready. Let me know when you're good, okay, Ariana? All right, so here we go. I'm just going to represent this by boxes to make it easy. So imagine me pushing or pulling a box. And my first example, I'm going to have positive 15 newtons and positive 25 newtons. And on the other side, I'm going to have negative 40 newtons. So I want everybody to figure it out. If you think you got it, raise your hand. And I want you to tell me the balanced or unbalanced and the equation I told you. Carlos. It is balanced. How do I know it's balanced? Very good. So I can add this together and I get positive 40 newtons, right? So you could either write it as negative 40 newtons plus 15 newtons plus 25 newtons, right? And then if you want, you can rewrite it negative 40 newtons plus 40 newtons. Do you guys see how I rewrote it and added them together? I highly suggest you do that when you have multiple vectors in the same direction, right? Make it super easy for yourself. And we know that equals 0 newtons. Somebody tell me what that means about its motion. What does it mean about the box's motion? If it's 0 newtons and balance, Christian. It's not moving, or it has one other option, not moving, or it's what? Decelerating would mean negative force. Accelerating means positive force. It could also mean what, Emerson? Yeah, constant velocity, meaning it's moving at the same speed. Because I'm not adding or taking away any force, right? If I was adding force, I'd be going faster. If I was taking away force, I'd be going slower. If I'm going at a constant velocity or constant speed and direction, I have no change in my force. It's all right. Yay! All right, let's try this one. All right, what do you think? I just had to do this one. I just made this up, so somebody new. Well, friends, if you guys get it first, you can raise your hand too. Tell me what the original equation is. Not when I rewrite it, but tell me the original equation. Carlos. Newtons. Okay, I'm gonna do all of them, right? Plus 47 newtons, plus 38 newtons, plus 56 newtons, right? Then I can take these and all add them together and rewrite it. That way I'm not skipping any steps, right? It's always best to just rewrite in math so I don't skip any steps. So I have, and I'm always gonna put my negative first just to remind myself that I have a negative, right? We don't wanna lose track of it. So negative 162 newtons plus, who else got what Carlos got? What did you get? That's what I got too. Anybody else get that? Okay. Plus 141 newtons equals, do I have more negatives or positives? More negatives or positives? Which number is bigger? Very good. So my answer is going to be negative because this number is bigger than this number, right? So it takes that sign. How much greater is it? By 21. What am I missing? Direction. What direction am I going? To the left. Now, somebody tell me as our closing remark for the day, what is the motion of this object? What is the motion of this object? What is happening to it, Caroline? It's getting dragged. What's our science word for that? Huh? Okay, it does have air resistance, begins with a D. If it's not getting faster, it's getting decelerating. Very good. So decelerating. Very good, guys. Very good. We're going to continue practicing this on Friday, and you'll have like a mini quiz on it, just to make sure you understand it before we move on to motion, understanding, taking the forces and then applying them to the motion of objects specifically.